Hello everyone, welcome back to the channel. So today I have a skill learn. So as I spoke in the last session, which is a machine learning topic in that video. So I said I'm gonna come up with a separate video on Scikit-Learn. So let's jump into the video by starting the introduction to uh, Scikit-Learn. So which is a very important library, and also so we must have a proper knowledge about this sklearn when we wanted to do some apply some machine learning algorithms. So if I wanted to import some data sets from the sklearn, so I have included end to end all the steps, as well as what are all the use cases of this sklearn, from selecting a data set to the deploying the model. So I'm going to cover all these things in this tutorial. So it is going to be an interesting session, as well as some libraries. So sklearn is a powerful and widely used open source machine learning library in Python, and it also provides simple and efficient tools for data mining, data analysis, and machine learning tasks. The library is built on top of NumPy, SciPy, and Matplotlib, and it also integrates seamlessly with these libraries. So which is made on top of NumPy, SciPy, and Matplotlib. So as well as it can integrate seamlessly with these libraries. So let's talk about key features of sklearn. So which is a comprehensive suite of algorithms. So it and also supports a variety of supervised and unsupervised learning algorithms. It includes linear models, support vector machines, decision trees, clusters, and more. So these are all the sample examples where this scikit-learn will support. So examples are like linear regression, support vector missions, decision trees, clusters, and many more. And also user-friendly API offers a clean and consistent interface for training models, making predictions and evaluating performance of the model, and efficient implements. So it provides optimized algorithms for performance and scalability, enabling handling of large data sets. So that is the goodness of this sklearn. So we can able to handle large data sets by using sklearn. And pre-processing tools, including utilities for data pre-processing, such as scaling, normalizing, encoding categorical variables, and feature selection. So these are all the things we can do with sklearn. So so we are going to talk about the scaling, normalization, encoding categorical variables, all these things with a simple small data set, so that we will get a clear cut idea of how this works. So let's start. Then here comes the model selection. Offers tools for model selection and hyperparameter tuning, such as cross validation and grid search. So let's start with a welcome note. Then, so if you wanted to install the sklearn, which is not installed earlier, then you need to use pip install sklearn, then enter it. Then it will be installed in the Python environment. So here it is installed, and you will get these messages, something like that. So it a requirement already satisfied, something like that. That means it's already installed. So if you wanted to install the sklearn in the Python environment, then use this command pip install sklearn. So I just wanted to I included NumPy, pandas, sklearn, matplotlib, all these things. So you can, if you wanted to include all the libraries at a time, also you can name all the individual libraries by providing a separate space between the library to library. Then you can install all together, because that is. And also, and the best thing about sklearn is like sklearn has some inbuilt data sets where we can uh, So no need to take the data from outside, no need to read the data. So here you can have, if you wanted to practice or if you wanted to do build a machine learning model on a simple data set, so you have inbuilt data sets within the sklearn, so where you can load the data set from the sklearn, then you can do, or you can prepare a model out of that data set. So that is what, so I'm just importing, this is an example case, how can I import a data set from the sklearn. So I'm just importing pandas because it is useful for data manipulations, and cborn if I wanted to show something a visualized manner, and same thing for matplotlib. And this is what, from sklearn dot datasets I'm importing, this is my dataset name. So this is an inbuilt dataset which is available in sklearn. So if you wanted to import a dataset, you need to mention this line sklearn dot datasets. Then import fetch California housing. So this is my dataset name. So then as soon as I imported fetch California housing from sklearn dot datasets, then if I wanted to read the data, so now I'm naming, since it is a California housing dataset, I'm assigning California variable is equal to fetch housing California. Whatever the data imported from sklearn, I'm assigning it to California. Then if I want my data frame, because this fetch California housing data frame, if you wanted to look at the keys what it has, so you can see here, because I assigned it to California. So if I wanted to look at the keys California dot keys, if I apply this, so you'll be able to see. So it has a data and also target variables, frame, target names, and feature names, and also the description of the data set. So, and I wanted to select a features and also target variable from the given data set. So here I'm creating a data frame, pd dot data frame. Here my data is California dot data, because California, in my data set California dot data will give me my data, and columns I'm giving is equal to California dot feature names. So my data set is California, and dot feature names will give me the columns. I want columns to be my feature names. And I want the target variable is here. We have a separate key for target also. So my target variable is like California dot target. So because whenever we wanted to build any model, we want some features x, x1, x2, x3, and also we want some output variable, which is y. So that is why I split the data with the input features as well as a target variable. So here my input features are California dot feature names, and my target variable is California dot target. So if I wanted to look at the data df dot head, so this is my data. It has so these many rows, and obviously this last column is my target variable where I wanted to predict the house price. So based on this all input features, so this is my value. House value is the target, the final uh, output, or I can say the predicted value. So we are gonna predict the house values based on all this input features. So it could be like so house age, how old the house is, and also average rooms, average bedrooms, and also the population in that particular area, revenue, occupancy, and also latitude, longitude, and also the final house price. So we are gonna predict these house values based on this all the features. So that is why I gave my df is California dot features, and my target variable is California dot target. So this is how, if you wanted to import other data sets also, you can import from sklearn dot datasets. So here you need to mention the specific data sets, whichever you wanted. If you wanted to work on Boston, then load Boston. If you wanted to work on a breast cancer data set, then you need to mention the respective data set name here, so that it will be imported from the sklearn datasets. So once it gets imported, you need to do the segregation part, like what are all the features, and you need to select the feature selection as well as the target variable, something like that. So this is how you can import data sets, inbuilt data sets from the sklearn. And data pre-processing. So I have imported the data successfully and I have to pre-process the data. So the pre-processing the data includes handling missing values, encoding categorical variables, and also scaling features. So if I have any missing values in the data set, I need to fill those missing values with the required condition. Like if it has categorical variables, I need to fill it with as per the condition or as per the use case, as per the problem statement, we need to fill the null values. Since my data set do not have any null values, so anyhow I covered this filling the null values in pandas, basic pandas in tutorial. So here we are gonna cover about one hot encoding and also the standard scaling. What does it exactly means? So one hot encoding with the Scikit-Learn, which nothing but it will convert the categorical variables into a numerical. It will convert the categorical variable. If I have 3 4 categories, then it will be converted into the respective numbers 0 1 2 1 2 3. It will be converted into the numeric digits so that the machine will learn from it, because we cannot directly feed the data as it is. So if I have for example, so so if I have a sample data set, so here the syntax to import the pre-processing. So here I am importing sklearn dot pre-processing import one hot encoder. So if you wanted to import one hot encoder, so you need to do, or you need to use this syntax sklearn dot pre-processing. For example, if I wanted to import a data set, then import data sets here, data sets, then the name of the data set. So here in sklearn dot pre-processing, we have a lot of things. Out of lot of things, I wanted to import one hot encoder, and this is my sample data. So if I wanted to look at the sample data, this France, so I have countries: France, Spain, Germany, Spain, Germany, France, Spain, France, Germany. So I have 3 countries. So this is like my country column is a categorical variables with 3 different categories. And my age column, it is a numerical, it is salary column is also numerical variable. So I'm converting this dictionary into a data frame, pd dot data from data. So this is I'm naming this as my original data set. So this is my original data set. So now I wanted to perform one hot encoding using sklearn to convert the categorical variable into a numerical thing. So this is how we can do. Encoder is equal to one hot encoder. Since I imported one hot encoder from sklearn pre-processing, so now I am assigning this one hot encoder to encoder, and I'm giving this sparse is equal to false. Then encoded features. Here I should be able to convert the features. So encoder dot, because this is my encoder, because I assigned one hot encoder to encoder. So encoder dot fit transform. Which one you wanted to transform, or which column you wanted to convert. I don't want to convert age column and salary column because these are already numerical. I just wanted to convert the categorical column, which is a country column. So that is what fit transform. Then you should pass that column, categorical column, df dot country. Then I'm creating this encoded df pd dot data frame encoded features comma columns is equal to encoder dot get features names out country, and df dot country. I'm just deleting the original country, same data set I'm using, but this time I replaced my like this categorical variables into this after encoding. So drop country access one, join encoded df. So I'm just joining encoded df so that the original country will be replaced by this encoded country column. So if you wanted to look at, if I run this code, then so this is my original data set. Original data set has country, 3 different countries, a categorical variable. So this a name has a numerical variable and salary is also numerical. Then after encoding, so this is the output I'm looking at, because this names has been successfully converted into ones and zeros. See, you can see here the country France new column will be created. Country Germany, a new column has been created. Country Spain, a new column has been generated. And also in the respective manner where the 44 and 72,000 salary is there. So it has been filled with the one value. So where the France is there, it will be replaced by one and the remaining values replaced by zero. Similarly for the Germany country and also for the Spain. So that means this column has been successfully converted into this readable format, machine readable format, zeros and ones. So this is the use of a encoder in order to convert the categorical columns into numerical ones and zeros, so that the machine can understand by looking at, if I feed this encoded data, then the machine will be able to process the data. Or else if I directly feed the data with this categorical columns, then the machine will not able to read the data properly. So that is about one hot encoding. And standard scaling with sklearn. Standard scaling is nothing but so first talk about the simple code with the data set. So if I wanted to import a standard scalar, again this is a step of pre-processing only. So that is why I'm importing from sklearn dot pre-processing, I'm importing this standard scalar to pre-process the data. So this is my data set. So I have age and salary data set. So age and 44, 27, 30, 38, 40, 35, 52, 27, 48, something like that. And salaries of that particular age group people. So the necessity of doing the scaling is like, so this number has a different value and this number has a different value. So if I take this 44 and if I mention 44 in the salary section, so that doesn't mean that 44 that doesn't have any like value. And if I mention the 72,000 age column, that doesn't have any value practically. So that is why I wanted to scale these values so that the machine can understand uh, easily or in a readable format, something like that. So that is why I just converted this data to a data frame. Then my scalar is a standard scalar, and scaled features is equal to scalar dot fit transform. I just wanted to transform entire data set because I wanted to scale these two columns. I have only two columns, so that is why I passed entire df. So df dot scaled pd dot data frame scaled features, comma columns is equal to age and salary. I'm assigning age and age and salary columns, and print standard scaled data set and df scaled data set. So this is my original data set. Original data set, age 44 and scale salary 70,000, something like that. So same original data set, and after scaled. So this is how the data has been scaled. Then before preparing a machine learning model, we need to perform all these things so that the like the we will get the a good efficient model, or model will perform a better results if I feed the new data also. So without performing this scaling and also one hot encoding, so we may not get the accurate result. So we must do this standard scaling and also one hot encoding. So one hot encoder is nothing but converting categorical data into numerical form, and this standard scalar is like with the units, different units data to a standardizing standards values. This is how we scaled the original values to a scaled data set. So this is about one hot encoder and standard scalar. So same thing, we are imported one data set right here in the above. So I just imported fetch California housing. Now I wanted to do this same things, one hot encoding and standard scalar for my above data set. Here I just took different examples, simple examples, so that we'll be able to understand what exactly it does, one hot encoder, and what exactly it does the standard scalar. So that is why I just took a different data sets. So we will be back to the original data set. So now I wanted to select the model selection. Now I wanted to, I have the data set, the California data set I have. Now I wanted to train and test the data. I want to split the data set into training and testing data set. So training data set, we will train the model, and the remaining testing data, whatever we trained, and we are going to test the testing data. So that is why I imported sklearn.model selection, train, test, split, then pre-processing, standard scalar and one hot encoder, and sklearn import simple imputer, and sklearn.pipeline import pipeline, and compose import column transform. So I have imported all necessary libraries. So now I'm just splitting the data into training and test sets. So I'm naming my x and y variables. So x is nothing but input features, and y is my target variable. So I want all the columns except this target variable from the df. So that is why df dot drop. I don't want this Meadows val. On axis 1, I wanted to drop this. So if I drop the only column, then I have all the other columns which are there here. See, this is, I just wanted to drop this column from the data set, so that all these features are my x values, and I am assigning this to y, df of Meadows value. So this is my y and x. So now I am, whatever I imported, x train, x test, y train, y test. So now train test split, I'm passing my x and y variables. So I'm giving the test size is 0.2. That means 80% is training data and 20% is testing data. Test size, I wanted to test on 20% data. So if I take my California data set as 100%, so 80% I'm assigning it to a training data. So model will learn the patterns on that 80% data. And if I wanted to test out of the after the training process, if I wanted to test, so I put 20% aside so that I can pass the testing data to evaluate the model. That is why I pass 0.2 and random state is 0. So if you skip this also, nothing to worry. So pre-processing pipeline, so numerical features. So I am just segregating the data into numerical and categorical columns. So here, if I have any numerical, since my original data set do not have any categorical columns, but if I have, in case if I am working on a different data set, and if I wanted to convert categorical column, so I need to specify, I need to follow this process. So numerical columns, x dot select d types include float and int. So if I have a combination of all the data sets, so my numerical columns or features are only float and int, so dot columns, and categorical means object. So I just divided or assigned numerical features from the given data set x value, like I just selected float and int, and here I'm assigning categorical features is equal to x dot select d types include object. Then numerical transform, so numerical transform is equal to pipeline steps is equal to imputer comma simple imputer strategy is equal to median, and scalar is equal to standard scalar. So categorical column is equal to pipeline steps, imputer is equal to simple imputer, strategy constant, fill value is equal to missing. And here I'm using one hot encoder because I'm working with a categorical variable. Here I'm working with a numerical variable. That is why I used scalar is equal to standard scalar. So here I'm using categorical. I'm using categorical columns. So that is why I'm using one hot encoder. And a preprocessor column transform is equal to number numerical transform comma numerical features, categorical transform comma categorical features. So this is my x train and x test after scaling the data, or after converting, after using the one hot encoder. So this is my, here I just segregated the data, I splitted the data 80-20, 80 for training and 20 for testing. In 80, I wanted to scale the data so that the machine can able to process it and able to identify the patterns with the scaled data only. So we will get a good result if I scale the data. So this is a process of doing scaling and one hot encoding. So this is my after pre-processing extrain x test, fit transform extrain, fit transform x test. So we are done with the data pre-processing. Then we need to model selection and training. Now, I just imported just to show you guys how to import different types of algorithms. So that is why I imported all the models. So if I wanted to import a linear regression, a ridge, lasso, elastic net, then I have to use sklearn dot linear model. Then import. After the import, you should mention the algorithm you wanted to import. And if I wanted to import a decision tree regressor, then sklearn.tree import decision tree regression regressor. So if I wanted to import mm, a random forest, so sklearn dot ensemble import random forest regressor, gradient boosting regressor. And so if I wanted to import svm support vector machines, then sklearn.svm import svr. And if I wanted to use the k nearest neighbor, then neighbors sklearn.neighbors import k nearest neighbor regressor. And if I wanted to use the neural networks, sklearn.neural networks import mlp regressor. And this is for Gaussian process, import Gaussian process regressor. So that is based on the model you wanted to use and based on the data. So what is the machine learning algorithm you wanted to use, then you can use as shown above, like this. We can import the required or necessary library like this. So now I just wanted to use the linear regression. Since I my house prices are numerical prices, and it is I just wanted to predict a continuous variable. So house prices are the continuous numerical variables. So I can use linear regression. So that is why my model is equal to linear regression. Model dot fit. I'm passing my training data x train and y train. So I mean I fitted the data, then the model coefficients and the model intercepts I'm giving. So this is what I got if I run this. Then after that, the model evaluation. So I trained the model, and I the data also fitted here, model dot fit. So now I wanted to look at the evaluation part. It evaluates the model using appropriate matrices. Since I am talking about a linear regression, so I can able to evaluate my model with mean absolute error, mean squared error, and also root mean square error and R2 score. So that is why. So if I wanted to import this model evaluation matrices, so I need to use from sklearn.matrix import mean squared error and R2 score. So predicting the test set result. So now I'm done with the training part. Machine has been trained. Now I wanted to test. So predicted value model dot predict. Then I am passing the remaining 20% x test value. Now why predict values? I got it. Now model evaluation. MSE is equal to mean squared error. So this mean squared error, and I need to pass y test and y predicted. So these are my original tested value. Then these are my predicted values. So it will give me mean squared error means the square mean difference of these two values. Then R2 square, I passed y test and y pred. So if I print this course, though I'll be able to see see here. I wanted to see these values with the scatter plot. So this is how linear regression line. So you can learn. So it is a linear relationship, actual values and predicted values. So you can see a straight line here, something like that. It is a linear line. So it is that thing which nothing but the model is performing better. And here we got a mean squared error is 0.5. So anything which is less than 1, which we can say that the model is performing better. So this model is whatever we build or we created the model which is performing good. So that is how you can select a model and you can evaluate the model performance. So this is how you can evaluate the model. And hyperparameter tuning. So hyperparameter tuning refers to the process of selecting the best set of hyperparameters for machine learning model. So hyperparameters are the parameters of the learning process itself, which are set before training the model, not learning from the data. So we need to set these values before the training the model only, not after training. and it's not going to learn from the data. So examples of these hyperparameters, including the learning rate, the number of epochs, and the number of layers in the neural networks. So we need to assign these values before training the data. How many layers you wanted, how many epochs you wanted. This thing we need to predefined, and the depth of a decision tree, the number of clusters in k-means clustering. So we need to mention that k value in k-means clustering. So these are all the things we need to predefine it before the learning only. So this is a simple example use case with the code sklearn model selection import grid search cv. So I'm defining my parameter grid. So this is how you can use the hyperparameters with the. This is a simple example. Grid search is equal to grid search cv model. This is para grid, and cv is equal to 5m score is equal to auto I'm giving this is like a hyperparameters. This is how you can I mean these hyperparameter tuning. And the next thing is like model deployment. Model deployment refers to the process of making a trained machine learning model available for use in a product environment where it can provide predictions based on new data set. So I just prepared the machine learning model, and it is ready to for the new data. If I pass the new data, then it has to be predicted based on the historical data I gave in during the training session. So this step is critical for turning a machine learning model from a development stage aircraft into a real world tool that can be deliver value in business applications, software systems, or user interfaces. So this is an example of how we can. There are a lot of ways. So this is a one way to deploy the model. Import the job lib. Then I have to save the model like this, and I have to load the model like this. So this is how the uses of the sklearn, the all these things. I covered almost everything, every bit of use of sklearn in this tutorial. I hope you will get a nice idea after once you complete this tutorial. You'll be able to understand what are all the use cases of this sklearn. So if you wanted to import the data, starting from importing the data, then as soon as we import, we need to uh, like split the data like x test x train. Then we need to do some pre-processing like handling the null values or scaling the values or converting categorical to numerical values, something like that. Then once we're done with all data pre-processing things, then we need to select model selection. So use the model as per your data or as per your target variable, which one you wanted to target. Like your target variable is a continuous numeric variable, then you should use the linear regression. Or if is it a uh, binary classifier like zeros and ones, yes, no, something like that, then you can use logistic regression. So as per your problem statement or as per the data you have, then you should select the models from sklearn dot linear model. So, and also we spoke about this model evaluation by using this sklearn dot matrix, and also hyperparameter tuning, then model deployment. So these are all the things we covered. So I have covered everything with the sklearn. So I hope after watching this video, you'll be able to get a nice idea about sklearn. So please like, share, and subscribe the channel. Don't forget to subscribe the channel. So if you are getting something out of this kind of videos, so and also if you have any questions or if you want me to cover a different topics in coming videos, feel free to mention the comment as well. What are all the things you wanted to be included in the coming videos, or you wanted to make, you want me to make a videos on different topics, that is also you can comment there, so that I'll be able to collect the required data, and also I'll try to do a video on the topics. So that is what I have. Thank you so much, everyone. Bye.